Hello, I am Farid, and in this short video I will have a revision of ODEs or ordinary differential equations and the application of ODEs in the vibration. Okay, so let me start here. Okay, so we will have a very short revision of ODEs. First of all, what's the general form of the ODEs and the general form of this type of equations? Here we will have a general form. This is an equation of ordinary differential equations, and in the right hand side we will have GT. In the left hand side we have the equation, and in the right hand side we have the non-homogeneous term of the equation. Y or yt is the unknown function. In fact, the purpose of solving this type of equations is to find this y. And t is the independent variable, and in vibration we deal with time because our problem is a time dependent problem. And finally n, which is the order of the equations. So we can determine the order of the equation from n. Generally, an ODE can be in different forms, for example linear or nonlinear, and it relates to the relation between y prime and other unknown functions. And second, it can be homogeneous or non-homogeneous. As I told you, if gt in this equation was 0, it will be a homogeneous equation, and if it was not 0, it will be non-homogeneous equations. And in vibration we call this free and forced vibration equation. In fact, this gt is an external force which appears here as a non-homogeneous term. And finally, it can be constant or variable coefficients, and again it's related to the coefficient of y prime, and generally all of the unknown functions. But a good news is that in this course in MM366 we deal with only linear second order ODEs with constant and real coefficients, and so we will have only linear and with constant and real positive coefficients, but we will have both homogeneous and non-homogeneous equations. Okay, so the general form of the equation that we deal with in vibration in MM366 is in this form: a naught y second plus a1 y prime plus a2y is equal to ft. As I told you, ft is the non-homogeneous term. So according to this ft, we will have two different solutions. The first one is the homogeneous solution when we consider that ft is equal to 0, and the second solution is the particular response, which is related to ft, and its form is directly depends on the ft form and ft function. Okay, so first we find the homogeneous response. The homogeneous response, or as I told you, free vibration response or transient solution in vibration we call it. We can consider the response in the general form of this exponential function, exponential alpha t, which alpha is in fact the eigenvalue of the equation. If you substitute this form in the main equation, you can extract the characteristic equation. The characteristic equation here you can see for this general form is a naught alpha squared plus a1 times y alpha plus a2 is equal to 0, and we consider that ft is 0 to find the homogeneous response. So this is an algebraic equations from order 2, so it will have two roots, and according to the quantity of a0, a1 and a2, we can have three different cases. The first case is we will have two real and distinct roots, or we can, in the second case, we can have two complex conjugate roots, and finally in the third case we will have double roots. For these different cases we will have different responses. So the real and distinct roots, when we have two different alpha 1 and alpha 2 roots, the homogeneous response is in this form: c1 exponential alpha 1t plus c2 exponential alpha 2t. And for the complex conjugate roots, we will have the homogeneous response in the form exponential rho t, which rho is the real part of the roots, and theta, which is the imaginary part of the roots. So again we will have two constants, c1 and c2, c1 times by cosine theta t and c2 times by sine theta t. And finally for the third case we will have double roots in the form of alpha. So the homogeneous response will be exponential alpha t c1 plus c2 t. To find c1 and c2, which we call them constant coefficients, we need some initial conditions. Here we have two constants because the equation was from order 2, so we need at least two initial conditions or boundary conditions to find these two constants. Okay, and finally we need to find the particular solution, or in vibration we call it forced vibration or steady state response. Okay, so as I told you, to find the particular solution, we, according to the form of the non-homogeneous term, we will find the particular response. And here we consider three different cases. The first case is when ft is a polynomial of order n, so we can consider that the particular response is again a polynomial from order n. You can see d0 plus d1t plus 2dn times by t to the power of n, and d0 to dn are constant coefficients. So this is the particular response. If ft was an exponential form, or it was an exponential function, we should consider the particular response exactly in the form of that exponential coefficient with a unknown coefficient, unknown constant coefficient d0. And finally, if ft or non-homogeneous term was in cosine or sine term with a frequency beta, we should consider the particular response in the form of a summation of cosine and sine functions with frequency again beta. It's very important, both of them should be in the same frequency with two constant coefficients d0 and d1. Again, to find d0 to dn, we should substitute this particular response into the main equations and find these constant coefficients. Okay, and this is the total procedure to find the particular and homogeneous response, especially for the second order ordinary differential equations, and we need these solutions for vibration or MM366. And here it's very important questions that I want to pose here, and you are supposed to answer this question in the forum, or you can send me an email. Why the particular solution is called the steady state solution and the homogeneous solution is called transient solution? I mean, in vibration we call the particular solution or the non-homogeneous solution, we call this steady state solution, and the homogeneous solution is called transient solution or free vibration solution. What's the reason of these names? And you can explain this with an example. And by this question I will wrap up this part, and thank you for your attention.